Hey QED coders, Michael L. Perry here. We are going to be doing some live coding, and this is Groundhog coding, so it's Groundhog Day again. Groundhog coding is all about building an application from scratch, seeing how far we can get, and at the end of it, we have to throw it all away. So, what we are going to be trying to build is yet another chat application, Yucca. We're going to build it using Jinaga, and this time around, we're going to build it using React. So let's see how React works with Jinaga. In the last episode of Groundhog Coding, we used Webpack and the TypeScript compiler in order to use Jinaga with TypeScript. This time around, we've got a starter kit. In fact, we've got two starter kits. One for Jinaga, or one for JavaScript, one for TypeScript, and we choose whichever language we want to use. So I am going to choose this time around the JavaScript language. We will start up our application and we will do some live coding with Jinaga and React. All right, so to get us started, let me go to jinaga.com. So this is your home for learning about Jinaga. And if we take a look in the docs now, we've got some starter kits. So the starter kits include TypeScript and JavaScript. So we're going to use one of these starter kits. But first, let's explore the application that we're going to build, and let's see how that works with Jinaga. Also up here on the docs, we've got references for all the different things you can do in Jinaga. And within each one of these references, we've got sample code, and we've got a little try it button next to the sample code that allows you to run it. So you can just hit run, you can see what the output's going to be. So in this case, we're running the sample that creates a fact. Now, a Jinaga fact is a JSON object that has a type. And you can see here, we're just writing that back out. There's that JSON object. So let's suppose that rather than some tag for a blog engine, I wanted to write a message in yet another chat application. So I could do const message is new Yucca message, and the text of the message will be hello world. Now let's go ahead and write that message out, and you can see there is our JSON object that represents the Jinaga fact. So that's pretty simple. Now let's say in my chat application I want to create messages inside of channels. So let's suppose I've got a general channel. I can do that by saying my channel is now another object. It's another Jinaga fact. So this is going to be type Yucca channel. And I want the name of the channel to be general. Okay, so run that, and that's what you get. You've got the message is in the channel. It's just a regular old JSON object. Now, this relationship here of the message knowing about the channel, this might seem a little bit backwards. Usually you might think, well, I need a channel and all of the messages that are in it, so I would need an array of messages. So it's the opposite direction. The child knows about the parent. That's an important thing to the way that Jinaga works, because now I can use this in order to run a query. So let's take this channel and let's extract it here. So there's my channel JSON object. And what I want to do is run a query starting from that channel to find all of the messages that are in the channel. So to do that, I can say const messages equals await, because this is going to be an async method, j.query. So j.query, I have to tell it where to start, and I have to give it, it says here, a preposition. This comes from a template function. Let me show you what that is. The start is the channel. So just starting from the channel, and the preposition is j.for. That's how I get a preposition from a template function, a specification here. So I want to write a function. This is what a message in channel C looks like. This is going to match, so I use j.match this template. The type is yucca.message, and the channel is C. So, message in channel, that's my template function that describes the shape of a message. So this message right here is going to match that shape for channel, for this channel C. So, query channel for message in channel, and this, I make this mistake quite a lot. You can see this function is a void function. It needs to return the match. That way it's a specification. So that's what makes this a template function. So now I do j.for, that specification, and that's what gives me the preposition that I can then query. So return the match, and now this is going to find all the messages that match that shape for that particular channel. So let's go ahead and write those out, run it, and you'll see, here we go. We've got the text hello world. That is a message inside of the channel. So the same object we were seeing before, but now you see it's coming back in an array. Because what I can do is I can say, hi, here's another message, run that, and now my array has two objects in it, because I already emitted this one as a fact, and now when I ran it this time, I emitted this one as a fact. So now there are two facts that match that template, and so I get them all back in the query. Okay, so we're starting to explore the model that I would be building my application on top of. Let's do one more thing here. Let's say that I want to keep track of the sender. So the sender will be a Yucca user, and we'll say that their name is Michael. So now I can run that, and you can see that this time I've got my two messages from before, and I've got my third message from the sender Michael. So even though it's the same text, this is a brand new fact because it's got new information in it. It's got a sender now. And so this is what I want to do within my application, is I want to know who is the sender, what's the channel that they're putting the message in, and what is the text of that message. And so this is going to be the structure of those facts. So with all that in mind, let's get into a Jinaga application, and then let's bring in some React, bring in the Jinaga model, see if we can build this out. Okay, so let's go back to home. Here we are. We're going to get started, and this is where we'll find our starter kits. So we've got our TypeScript starter kit and our JavaScript starter kit. I want to do the JavaScript starter kit. So let's copy all of that except for the folder name right there. And let's go. Let's go to, I want to go to my Ubuntu window right there. Okay, change to Mount C projects And there's all my projects, all the stuff I'm working on. Let's go ahead and export starter JavaScript to Yucca. So if you don't have Subversion installed, then this command won't work for you. You could either go ahead and install it, or you can download the starter kit straight from GitHub. So you just click over here, clone or download the zip, extract it into the folder, and you're good to go. But by using Subversion export, we get all of the files. They're all set up in the right folder, and we're not cloning this repository, so we don't get the entire history, and we don't have a connection to any source code repository upstream. So this isn't a fork. It's just brand new, empty application. And so now that we've got this, what I can do is I can start up Visual Studio Code. And inside of Visual Studio Code, I will make sure that I open the folder nice and big. Yucca. There we go. All right, so this is the Yucca folder. Yet another chat application. Let's take a look at what the starter pack gave us. Inside of source, we've got client code and we've got server code. So we've got some JavaScript code to kind of help us get started. A little bit of instructions right here in the README. These instructions are also visible online if you follow that link to the GitHub repository. And so that tells you how to get things started. There's the Subversion export command we just ran. And so the next thing that we need to do is an Npm install. I'll use Npm CI. That's kind of a different version of install that works a little bit faster, and it whacks your node modules and downloads everything. But that version only works if you have a package lock JSON. So it doesn't change things because you've installed new packages or anything. CI, it's for your CI servers. It's like, hey, let's start from scratch and rebuild our application. So that's really what we're trying to do right here. Start from scratch, build the app. And so this is pulling down all of the node modules. So after it finishes walking through the tree, you'll see node modules pop in at the in the browser up there, or the Explorer. Oops. Aha. Why is it? Oh, okay, Yucca node modules, right? Yeah. Okay, there we go. There's the node modules. It just took a while before it would rescan it. Okay, so we've installed all of our node modules. Those node modules include the greatest hits, like Express and Jinaga and Postgres. It also includes some dev dependencies like Babel and Webpack. So these are going to help us to build our application. Then we need to do some database setup. So we can use Postgres to run the setup SQL against an application or a database that we want. Actually, this command line is not quite right, so we've got a little bit of work to do there. But let's take a look right here at the Postgres setup, and we can see this is how we set up a Postgres database for Jinaga. This starter kit is intended to be used against a Postgres database because we want to preserve our facts. So I need to create a database. Let me go ahead and do PG SQL, and I want the host, or not PG SQL, pSQL, PostgreSQL. The host is localhost, and then the user is Postgres, and the database that I'll start with is Postgres. And there we are. So now from within here, I want to create a database, and I'm going to call it Yucca. So create database Yucca. And the database, it is, that's pretty loud. It is created. Okay, now I need to create a user that has the correct privileges. As it so happens, I've already created this user because I've got other Jinaga databases on this machine. So I'll skip that step, but usually you would just copy this, paste it in there, and you will have that user. Then the next thing that you want to do is to go ahead and run this guy. So it's in node modules, Jinaga. So let's Control D to log out. And then I can say, I want to run psql, let's see, I think, trying to remember what the command line is. Psql execute script. Run a SQL file from the command line. And what you do is blah, 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 blah. -F. There it is, -F. Okay. So let's go ahead and refresh this guy and we'll see, yep, there's Yucca right there. Okay. And you'll see right now, Yucca is empty, no tables. Okay. So now I'm going to do psql dash, actually that right there, using the Postgres user, not using the dev user. The dev user, this is very important, the dev user does not have permissions to create a database, role, replication. They don't have the permissions to create tables. In fact, they don't even have permission to update or delete. Where was it that I could only insert and select? I forget which one of these actually says that. But the user should not be able to update or delete any rows because Jinaga is insert only. Okay, so now we run -t and node modules set up. All right. It's a good thing that it was ignored because I don't want to run that in the Postgres database. So what I actually want to do is use the Postgres user. Let me make sure that it's the user -u Postgres, and then the database is going to be Yucca. Okay. Database does not exist. I got that wrong. So psql help me. All right, I think -t is not what I thought it was. Okay. Let me go back to my help. Maybe I should actually read the question. Or -F. Why did I do -t? -ELS F. Yeah, F is file name. Okay. So I do a -F. All right, so let's try that again. So I want to do -F. So localhost, node modules, do, it says, or do not. So let's refresh our view here, and Ba-bam! We've got our Jinaga tables. There we go. So this is the correct command line. Let's copy that. And because I'm trying to make sure that I correct problems as I see them, I'll go ahead and make this change to jinaga.com, where here is my content. Here are my documents. So getting started, the Postgres setup. Okay. So that is a bash command. Boom. My application. That's what I called it up here. Yes, create database my application. Okay, so that's the name of the database. Okay. So that will help us in the future. I can use that command line. So I will check that in at some point, and we will have that change propagate up to the web page. In the meantime, so I've just created the Jinaga database. And so now I need to modify my Jinaga server in Jinaga config. So this says Yucca. All right, so there's my developer connection to the Yucca database. So here I'm not using Postgres as the username. I'm using dev as the username. So this is the restricted user, insert and select only. That's all they can do. So with these, now I should have a good application. So let's go back to package.json and see what I can do with this package. I've got clean, build, start, and test does nothing right now. There will be some tests in the future, but right now we can clean, that removes the dist folder, doesn't exist yet. Build, that runs webpack, and then copies the views to the dist folder. Here's my views right there. And start, that runs node with server.js. So let's run a build real quick. npm run build. I run that, so it's webpacking, and then it's copying the views. And so now I have a dist folder right here, and it's finished 2 different webpacks. It's done 2 things, one for the client, one for the server. The client code ended up in scripts, the server code ended up in server.js, and the views got copied in there as well. How did it know to do all that? Well, that's from webpack config.js. So here is how it builds the clients. It outputs main.js in dist scripts, so that's there. And it gets all of that from client and shared. We don't have a shared folder here yet, but we will. And for the server, it outputs server.js in the dist folder. That's there. And it gets that from server and shared. Yeah, I kind of see what that shared folder is for. It's for the shared code, the code that runs on the client and the server. Okay. And so we're running the Babel loader for that, and we're running the Babel loader for this. And so that gives us our client and our server. I should be able to do npm run clean. It deletes the dist folder. All gone. Npm run build. And so I've got my, my build scripts all working. So the next thing that I want to do is let's run the application. Okay, npm run start. Or I could just type npm start. And so that runs the application using Node. So I do that, and then I will end up with HTTP localhost 8080. Let's open that up, and I see welcome, you're visitor number 1. I refresh, visitor number 2, 3, 4. Fantastic. Shut it down, start it back up again. And when I refresh, number 5, 6, 7. Okay, so this is the stage that we got to last time. I've just bundled it all up into a starter kit, but it's storing these Yucca facts in the database, in the Postgres database. These Jinaga facts, I should say. But I don't want a page counter. I want Yucca. I want yet another chat application. So let's go to my index.js and let's change this. Let's turn this into Yucca. We don't want visits, we don't want domains, we don't want any of that stuff. And we certainly don't want to use document body append child to build our user interface. No, we want to use React. Okay. So you can see we've got Jinaga all set up and it's working. Let's switch over to getting React set up. Let's get that working. So for React to work, we'll want to, rather than having some hard-coded HTML in here, I want a place to drop the React application. So let's create a div. And the class shall be Yucca app. So that's a place where React can put an application. It can drop a component right there. So how do we want it to drop that component? Well, let's go back to index.js. And in order to drop a component there, I need to use React DOM. And in order to create the component in the first place, I need to use React. I don't have either of those in my node modules yet. They're not listed in package.json because this starter kit doesn't know that it's supposed to be a React starter kit. Let's go ahead and add those. Npm Install, save, React, and React DOM. So React is going to give me all of the runtime stuff, and React DOM is going to give me what I need in order to inject it into HTML. So bringing all that down, there it all is. You can see now I've got those two dependencies. They magically showed up in package.json. And so that means that now I can come up here and I can import React from React. You can see now it's in there. Import React DOM from React DOM. Very nice. So first of all, let's use React to create our application. So I'll create a class called app. Extends React dot component. Okay, and we want to give this thing a render function. So this is going to render my entire application. So for right now, let's go ahead and return. I always forget to do the return. I don't know why. Actually, I do know why. And so right now, it's just going to say h1 yet another chat app. Yucca. I prefer semicolons. A lot of people in the React community don't like the semicolons. Choice is up to you. That is optional right there. But okay, so we've got a component. It's going to render this h1 tag. And for those not familiar with React, you might be thinking, wait a minute, that's not valid JavaScript. That looks like HTML. You'd be right. That is very much like HTML. That's actually something called JSX. It gets compiled into JavaScript, and that JavaScript creates objects in the DOM. So that will turn into some JavaScript that creates an H1. So right now, I will bet you if I try to build it, it's not going to work because Babel doesn't know that it's supposed to turn that into JavaScript. So let's do npm run build. And let's see. Indeed, it fails. This is probably not a problem with npm. npm does a really good job of telling you it's not my problem. It's not my fault. Up here is the actual problem. So I would like for that to be the very last thing that I see, but npm likes to just give excuses instead of say, hey, there's the problem. The problem is that this is an unexpected token. That's not valid JavaScript. So we have to tell the Babel loader, we can see right here, Babel loader, that's the thing that's running this. We have to tell Babel that, that we want to support JSX. We want to support React. So the way that we do that is Babel loader React. We use a preset. So preset. If I search for that, then here it is. Babel preset React. That's the thing that I need to set up. So I'll take this, I'll install it. And notice the save dev because this is a dev dependency. So I'm going to install that. I'm also going to install Babel preset env. And this will set up the most recent version of JavaScript and compile it down to one that the browsers can all run. So, so that is the primary use of Babel. But using these two presets, then I can make sure that I can compile this. I can compile code that looks like modern JavaScript, but I can still run it in a browser, even if that browser is IE11. So it's installing those things. We can see them show up here in the dev dependencies. So right now we just have Babel core, which is a plugin for the Babel loader. Now we've got two Babel presets, env and React. So we have to go into Webpack, where we have configured the Babel loader, and we can add some configuration here. Although that would have to be done for both the server and the client. There's another place that we can do that. Right here in source, I'm going to create a Babel RC, and this is going to have, let me just make sure I get this syntax right. Babel RC presets. It's going to look like okay, there. It's going to look like this. Presets. It's just a JSON object. And this goes into Babel RC. So we do presets. Oh, hey, I could have just let IntelliSense help me. Hey, look at all that. Look at all that. Okay. And so the presets shall be, I believe it's just env and React. I think that's all you have to say there. I'm going to make absolutely certain. No, you actually do have to spell it out. Okay. There it is. Yeah. So @babel/preset-react. So @babel/preset-env @babel/preset.-react. So there are my presets. So that is going to configure Babel so that it can run modern JavaScript, it can compile modern JavaScript, and it can also compile JSX. So with that in place, I'm going to npm run build, and this time it should be happy. Be happy. Be happy. That looks happy. That looks very happy. Okay, so that allows us to compile our application. The next thing that I want to do is I want to use React DOM in order to render that application in this div. So I'm going to get the div by the name Yucca-app, and I'll render it. So React DOM render, and so now the React element, I can type this using JSX. So app, and close that. That's the instance of the app. This element here is the actual DOM element. So I want document get elements by ID Yucca app. And so that renders that application at that point. Save it, build it, and once it's done building, start it. There we go. Localhost 8080, refresh, and there's a problem. Where's the problem? Target container is not a DOM element. Yucca-app get element by ID. Oh, by ID, silly. ID. Let's try that again. Build. And start. Yet another chat app. There we go. We have React running in our application. So that's all it took to do that. If you're just getting started with React, I would recommend checking out this thing called Create React App. It is a bootstrapper and a runtime. So you can use it to actually create a React app from the command line, and you'll have a working React app all in one step. But then you can also tell it to go ahead and run the application. It starts up a server and serves up your application. It does hot reloading, it refreshes the browser, all that fun stuff. So it's a really great way to get started. But if you are building your own backend that you want to serve with the React application rather than as a separate application, so one thing that's the API, another thing that's the front end. If you want it to be together like we're doing here, then you can't use Create React App, or at least it's less useful. So here we're not using Create React App, but we are just putting it together by ourselves, and it's not that difficult. One thing I would like to do, however, is I would like to be able to change the application and see it refresh. So I make a change and hit save. I want to be able to refresh the page and see the change, and it's not working. So what I'm going to do, let me go ahead and kill the server here. I'm going to set up something that will refresh the application. It'll give me some live reloading. And after I go back and rewatch this, I'll remember, hey, I should add that to the starter kit. So what I'm going to do is I'm going to add a script called dev, and this one will do two things. First of all, it will call webpack -- watch. So this will watch for file changes and then recompile them. And then with a single and, so that it runs this in parallel, it's going to call node dist server.js, or in fact, npm start. So that way, if I change this, that change takes effect here. So this is going to start node, and it's going to start webpack, and webpack is going to rebuild the application as we change the files. So npm run dev. So this starts me up in developer mode. So I've got webpack watching the files, and the app is running at localhost 8080, and webpack is finished building. So here we refresh, and now if I make a change, save it, refresh, and now I can see the change. So I've got developer mode happening. It's not automatically refreshing the browser. That would be some additional work that I could do, but I'm satisfied with it just working like this for now. Okay, so we're looking good. Let's go ahead and shuffle things around a little bit to make them easier to keep track of. So I've got my my constant j. I'm going to be using this Jinaga instance in lots of different places. So let me go ahead and create a Jinaga -config JS for the client side, and that's going to be that much. So we're going to import the Jinaga browser, create the J, but now we will export that. So anybody can import J from this file. Case in point, here, wherever I need J, I can just import from Jinaga config, and there's J. So just import it, and now I've got all of my Jinaga stuff. So there's j.fact, so I can create facts, all that good stuff. Okay. Then I want to go ahead and extract this component. Let's take this whole component right here, this app, and let's create a folder called components. And inside of that, we create app.js. There's my app. I need to import React in order to make that work. And then I'll export that class from that component. And that way I'm just going to hit Control Space, and right here, auto import from component app. So that adds the import app from components app. So save it, it builds, and it still loads. Okay. So I'm looking, I'm happy with the way that's starting to come apart. So I've got my components here. I've got my application getting all set up. Let's actually start to build yet another chat application. So what is my chat application going to look like? Well, I want to, like right up here, I want to say this is channel general. Okay, so there's my general channel. Let's make sure, yeah, that's doing that. And then in here, I want a list of messages. So let's put those messages in an unordered list. And then each message is going to be a list item. And I'm going to want to show who it's from and the text itself. So who it's from, that'll be a span, and we'll use class name is sender, and it'll say Michael. And then we'll have another span, class name is text, and this will be hello world. So I'm putting these in spans so that I can write some CSS to style them. Right now, we're not going to worry about styling them, but it's all set up for us to do that. And boom, something's not working. And that's because adjacent JSX elements must be wrapped in an enclosing tag. Do you want to use a JSX fragment? But a fragment looks like this. It's got a tag that has no name, and then a closing tag that has no name. Why, yes, I do. Let me go ahead and do that. So we have my opening tag, my closing tag, all the stuff that goes in between. How about that? Do you like that? It seems to like that. So let's refresh, and there we go. There is my list item. Michael, hello world. So I can keep going like this, kind of specking out the application. And let's, like I can say, here's a message from Jenny, and Jenny says, hey, pumpkin head. And so now we've got Jenny saying, hey, Pumpkinhead. All right. So we could keep on going like that, but, repeating all of this stuff for every element, that seems like we could do better. It seems like we could use a component. So how about we do that? Let's go ahead and create a new file. We will call this menu item.js. We will import React from React. And then we will create a component. So I'll export. This time I'm going to export a constant called menu item. And this constant is going to be equal to a function that takes an object and returns open parentheses this. Okay. So again, I like the semicolon. This is the place where a lot of React developers wouldn't put a semicolon, but I like it there. And again, we've got some adjacent, wait, no, this is just one li at the root, so we're good with that. So this menu item is taking an object that then spits this out. What is this object? This object is the properties. It's called props. And so props is a JavaScript object that has one field for every attribute that you set on the element. So if I want to be able to set the center and the text, then I can destructure those into this function. So this props has these two things. And then I can say, put the sender here, put the text here, and I'm using curly braces because I'm going from HTML, JSX, into regular old Java. So I have to put the regular JavaScript. We have to put the regular JavaScript stuff in the curly braces. So there's my menu item. So now, rather than this, I can say I want a menu item, which I will import from /menu item. And I want the sender to be equal to Jenny, and the text to be equal to Hey Pumpkinhead. So that is the same as that. And in fact, that is the same as that. And I can keep going. So I can say, let's say that Andrea says, hello. So I've got these 3 menu items. And when I refresh, wait, there they are. Okay, so now I've decomposed my application a little bit into some additional components. So the next thing that I want to do is, rather than hard coding these menu items, I want to get them from some data. So let's suppose that I've got some messages. Okay? And I want these messages to be in an array. And they are objects that have a sender, like Michael, and a text, like hello world. Okay, so I have these messages. So there's that one. There's going to be Jenny. There's going to be Andrea. And let's do one more. Let's say that we also have David. And David is going to say, what's up? Okay, so I've got this data, all these messages, and I want to turn this array into a set of menu items. How do I do that? Well, I'm going to do that by using messages.map. So this takes a function like so, which takes an item like so, and that item has a sender and a text, because each one of those items is one of these guys. Okay, and so then that is going to yield open parentheses, because I don't want to run some lines of code here. I just want to return an object, and that object shall be this menu item, where the sender is sender and the text is text. Okay, so that will map those messages into these menu items. So I don't have hard-coded menu items anymore. Now I'm using the ones that are in the data. So run that, and now I should see what's up. Okay. So all this is starting to really come together. There's one other thing that the function receives, and that's an index, a number. So 0, 1, 2, 3, 4. 0, 1, 2, 3, that's right. So we'll call that index I, and here we will use that as the key so that we can reuse those menu items rather than having to re-render them every time. So just makes things a little bit faster. If you had the opportunity to insert or delete or rearrange within the list, you would want to reuse menu items from different places in the list, and then the key wouldn't just be the index. For that, you would want the key to be something that's actually unique to that message. But for right now, the index will be sufficient. So we've got those things projecting into the view. At this point, I want to get these messages not from this hard-coded list here, but I want to get it from the application state. I want that to be the application's data. So how do I do that? I set up a constructor. This constructor takes props. Those are the properties that are coming into the app. So just like here, I passed props into the menu item, sender and text, ended up as props. In here, that's the props object. This is what the props object coming into the app would be. And I have to pass that to my superclass. And now I can set up this class's state. So this dot state is equal to, I'm going to create an object and it will have messages. Initially, these messages will be empty. And so now, rather than using messages here, I will say this dot state dot messages. And I can use the messages that are in my application state. These, I will now, see, I didn't use the semicolon, and the world didn't end. For right now, I am going to say when the component did mount, then I want to set the state to a state where messages is equal to that guy. And back to me. Oh, world did not end. Okay, so saved, reloaded, and boom. Okay. So what that is showing me is I am taking this array and I am loading that into the application's state. So now the state is an object that has a messages field that is an array. Now, of course, I don't want to do that on component did mount. That was just there to kind of show you the whole thing working. Instead, what I want to do is I want to load those messages from Jinaga. So, how am I going to load messages from Jinaga? All right, so when I mount the component, rather than setting the state directly like that, I am going to set up a watch. Now, as we saw here we did a j.query. So I ran a query for the messages in this channel, and I got back that array of messages. But rather than query for an interactive application, for one that where the user is actually you're updating the user interface, the query would just give you back the objects at that particular moment in time. You want to know when something new is added to that collection. And so there you use watch instead of query. So I'm going to say j.watch. Well, where is j? Let me auto import that from Jinaga config. All right, there we go. There's j.watch. And so I'm going to watch from some starting point. Now that starting point will be the channel. So here's my channel. For right now, let's go ahead and copy that in there. All right, there's my channel. So I want to watch the channel. And now I want to watch for message in channel. So here's my message in channel template function. Let's go ahead and pop that right there for now. So j.for message in channel. But now watch isn't returning the results. Instead, it's taking results added. So this is a function that is called whenever there is a new message in this channel. You can see this version also takes, okay, yeah, this is the second version. The first one also takes a result removed. But for this one, we just have result added. So result removed would be called whenever that result is no longer in the template, and you therefore take it out of the user interface. But for right now, we're just using this one. So result added, that is a function that takes your message. And now I want to do something with that message. So I'll say this dot add message. There we go. So that's setting up my watch. Let's go ahead and implement message added, taking a message. And so this is where we want to add that to the application state. A new message has arrived in this channel. I want to show it to the user. So I do this dot set state. And so here I have to set a brand new state object. So that state object is going to have messages, and that's going to have an array. That array is going to have all of the existing messages. So this dot state dot messages, and then concat the new message that's coming in. So the new message is going to be an object that has a sender, which is a string, and text, which is a string. So these have to come from that message. This message in channel, that's one of these things. So we can see here are the messages in the channel. So if I want the sender, I have to go to the sender name. Well, I can deconstruct that into here. So that means that I've got a sender which has a name. And so that name goes right here. Okay. Also in this fact, you can see I've got a text property. So text is a property of my message, and so I can destructure it and I can put it right there. So this is going to add a little object with sender and text coming from this Jinaga fact. It's going to destructure that and put it right there. Now, if my state ever ends up with more than just messages, then basically set state like this, it's just going to whack all of the other fields. I don't want that. I want to also bring in all of the other fields from this dot state. So I'm going to use the spread operator. So basically take all of the fields in this state and spread them out as if they were right here. So here come all those fields, including messages, by the way. But then replace messages with this new array. In fact, I can use the spread operator for arrays. If I wanted to, I could say all of the elements in this array, and then there we go. Yeah. All the elements in this array plus this new element. So using the spread operators like this, we get kind of that balance of we're setting the state to this state and messages with the state messages and this new state. So we're setting that state. I like my semicolons. And so now we should have all of the messages that are in that fact. So let's refresh it, and all of my test data is gone. Now it's just the messages that are in the fact. Well, where are those messages? I don't have any way of creating one. I want to show you something real quick. This is a nice little debugging technique. So right now, I can't access my J object. Let me go back to my Jinaga config, and I'll just say window.j equals J. Okay. Now refresh, and there's my J object. So there's Jinaga. And now I can do stuff like Jinaga.inspect. I don't have any objects in my Jinaga store right now. But now I can also do j.fact. And I can create a Jinaga fact right here. In fact, in actual fact, I can create this message. Just so. So let's go ahead and copy that in. I think it's going to run into problems with the await. Well, that's interesting. It didn't run into any problems with the await. Now when I say j.inspect, now I've got some Jinaga objects in there. The thing that I ran into trouble with is add message is not a function. So let's go back here to my app. I called it message added, not add message. I like message added. That's a better name for it. Okay, message added. Sounds good. Okay, so let's refresh. And there's my message. From Michael, it says, hi. So how did that show up? That showed up because j.watch starts out by looking for any messages that are in this channel right now. So it runs the query, and for every result that it gets, it calls your function. And then, as the user interacts with the application, like for example by adding a new message, boom, it calls your function again. So all we need to do is call j.fact at the right time, and the user interface will update. And when we refresh the page, all of that data is still there. So that's one of the benefits of Jinaga, is that you just write a watch, write it once, and then you get this behavior, loading objects and responding to user events. Sounds good? Okay. Now let's kind of clean this up a little bit. You can see that right now this is doing a bit more than just rendering the app. It's got messaging channel, which is really part of my model. What I want this to be, should be in a separate model class, and in fact, it really should be shared between the client and the server. Where do we put shared code? Let's see. Inside of source, we will create a new folder called shared. And inside of shared, we will create a new folder called model. Because there might be other shared code, but this is the Jinaga model. And inside of there, I will create a message.js. And so this will be all the code related to messages. So message in channel, that will move here. Very nice. Okay, so now let's see where we're going to get J from. Well, there's one right here in client Jinaga config. It's reaching out to client from the shared code. That's going to work on the client side, but that's not going to work on the server. Okay, well, we need to bring in message in channel. Well, let me do an import statement, // shared / model / message in channel. All right. So now that's better. So message in channel was not found. I think that's the old error. Okay. And yeah. So this is where we run into that problem. So message in channel. Oh, I need to export it. How about that? Are you happy with that? Okay, yeah, that worked. Now, what I was expecting to run into a problem with, but I didn't actually run into the problem, is that you can't compile this code for the server. I think the reason I didn't run into that problem is because the server doesn't actually import this code. So it's not accessible from the starting point on the server, server.js. And so therefore it never gets hit. Doesn't matter. So one day when I do import this from the server, that's not going to be, it's not going to be satisfied with that. But you don't want shared code reaching back into the client. That's basically the problem. So what we can do is import from Jinaga, right? Now Jinaga doesn't export anything called J, but it does export something called Jinaga, and I can import it as J. So now J is my Jinaga class, and j.match is a static method on that class. So you can use J as an instance, or you can use J as the class. So this is the way that you would bring in that code so that it could be used on the client and on the server. And on the server, it wouldn't necessarily have an instance J. Okay, so now we've got our shared model. That's still working. That's all good. And the app is just the application. Now it does have this channel hard-coded right here in the app. I don't want that. I want to be able to point to any channel. So I really want this to be a parameter. So let's take this. I'm going to move it out of here. Let's go all the way back to index. Create my channel here. And I want to pass it in channel equals channel. Pass it in there, which means that from here, I can access the channel as this.props.channel. So we load that in, and there's my general channel. I can now take a look at random, and I haven't created any facts in random, so it's empty. Come back here, change that to general, and my facts are back. They were always there. It's just I was looking at a different channel. Okay, so let me clean this up. Control Alt O, clean up my imports. I'll do the same thing here. Control Alt O. Whoa. Control Alt O. All right. This is starting to look better. Now I want the user to be able to send a message into the channel. So how am I going to do that? I want to create a new component that is a form, a message submit form. So let's create a brand new component here called submit form.js. I'm going to import React from React. And then I'm going to export, well, no, here I'm going to use a class. Yeah, so export a class called submit form that extends React component. Okay, and here's my render function. Return. I'll do a form. And so this form, it's going to have your message. So label message, and then the place where you can actually type in that message. So input of type text, and the value shall be, well, let's get to the value in a little bit. All right, so there's my input. I want this to be the label for this input, so ID equals message text. So this is the label for message text. Okay. Then, after you've typed in that message text, you should have a submit button. So input type equals submit, and the value will put the text on this label, send. So there's my little form. That form is how I would submit things to the channel. Let's go ahead and save that. Now I can use that form right here. After my list, I will have a submit form. There it is. Let's import it. So there's my submit form. Save that and refresh the page. And there's my submit form. Oh, ha 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 ha. DOM property 4. Yes. Just like we're using class name instead of class, we have to use HTML for instead of for. Java keywords and JSX. But now you can see when I click on message, it highlights the input. That's how you know this is the label for that input. So I can say "'twas brillig," and then I hit send, and woo, it reloaded the page. Aha, that's because this form by default is doing a get on the current URL. So the method is get and the action is empty, current location. So I don't want it to do that. Instead, I want, when you click this, for it to take some action. So I will say on submit, that is going to be a little piece of code. It'll be a little function that calls this dot submit message. So what is submit message? That is a little function that's called right here. So window.alert submit. Okay, let's see that work. I'll refresh the page, I'll hit send, submit, but when I hit OK, still flashes, it still reloads the page. I need to tell it, don't actually do what the form was originally intended to do. And I do that by passing in an event, e, and then here I can say e dot this what is e dot prevent default? That's what it is. So prevent default. Yeah, you notice that little trick there? Up here, it knows what E is. It knows that it's a form event. And so it knows that prevent default and a whole bunch of other things are on form event. But once I call submit message, it no longer knows what the type is. Since I'm not using TypeScript, I can't do this. So I use that little trick in order to figure out what are my valid operations here. Okay, so now with that, let me refresh. I say "'twas brillig." I hit send, it submits it, and it does not refresh. So that is getting closer to the behavior that I want. Now, at this point, I want it to actually create that event. So I want this to use Jinaga to make that change. So that means that I need to capture the text. So the text should be part of the submit form's state. Constructor props super props this dot state is equal to text. Okay, so I've got empty text, and that means I can put the value of that empty text right here. Value equals this dot state dot text. So that goes in there, but you see that's not going to play nicely. You provided a value prop without an on-change handler. This will render a read-only field. What? Look, I can't change it. So you should be you should use on-change in order to capture the value that the user is typing in. So this is starting to get kind of long. Let me go ahead and wrap it. That way we can then say on change, I want to run a little bit of JavaScript. So I'm getting an event, and now I've got e dot, and look at all this stuff. What I'm after is e dot target. So e dot target now is the element that the user is changing. So one of the things that it has in here is all the way at the bottom. Wow, a lot of stuff. But value. So e.target.value is the actual value that the user is typing. So that means I can say this dot set text to that value. So set text, and that will be this dot set state. And now I want to set the state to an object where text is equal to the text that's coming in. In fact, I can just go ahead and say it like that. And just in case, in some future version of the world, we've got more things in here than just text, I will go ahead and use the spread operator. So I've got this.state with text replaced. So if I've got more properties in there, they will be preserved while I set the text. So now I refresh that. No problem there. I can type in "'twas brillig" and I hit send, and the text should be part of the state now. So in fact, I can see if I do this, this.state.text. There it is. Refresh. Submit "'twas brillig." All right. So I have my text. Now I want to create the fact. As it so happens, I have code right here that I've already pasted into the browser that creates that fact. So I don't want to do window.alert. I just want to run this code. But the text shall not be "hi." This text shall be this.state.text. There we go. So creating this message with this text in this channel. Here's the channel. Hard coding the channel again. That's probably a problem. But there's another problem in here I want to fix first. When I save it, boom, it fails. That's because await. Await is a reserved word. Yes, I know it is. But the whole point is this is not an async method. Maybe I could do this. That makes it happy. Wait a minute, does that make it happy? Yeah, that made it happy. But now I'm creating a promise that that I'm not actually consuming. Let's just go ahead and see that. Let's refresh. Regenerator runtime. Yeah, I'm thinking this is a problem. But yeah, the simple solution is I don't have to await j.fact. Yes, j.fact returns a promise, but I don't have to await it. I can .then. And now I've got my result. I have the fact right here. That's the message. And after that message, I can do something. What I want to do is this.set text empty string. Clear out the text field. That's what I want to do. So after we have properly saved the user's input, we can go ahead and clear the input field. So the promise returned from j.fact is resolved when that data has been persisted. All right, refresh. "'Twas brillig." Send. Boom. I say boom. So take a moment to think about what just happened there. So I called j.fact from here inside of this form. That means that it created this fact inside of that Jinaga instance. But this form right here, misspelled message. I'll fix that in a second. This component here doesn't know about the list out here in app.js. This guy is watching for messages in the channel. So when I create the fact that matches that template, then Jinaga is calling message added because I set up that watch. And so that is one of my favorite features of Jinaga, is that it separates the creation of the facts from their consumption. So in one place you consume facts, in another place you create them, and you don't have to worry about hooking those two things up. So here we're not passing events. We're not passing. Yeah, there we are. So here we're not passing handlers down from one level to the next. We are just using the Jinaga instance that's already out there. So similar to the behaviors that you get in Redux. So similar to those advantages where without Redux, if you want to add some new data to the application state, you have to pass an event handler all the way down. And then inside of that event handler, you bubble that all the way back up and you call app.setState. So Redux solves that problem by putting the store into context and then using the reducers whenever you take some action. So Jinaga is kind of playing that role. By doing it this way, we can also see that it's loading things from the database, loading them from the server all the way through the API whenever you load the application, and using that same watch in order to display those things on the user interface. The same watch that it uses to respond to user actions. So you just watch for facts. Doesn't matter if they happen before or if they're happening right now. In fact, it doesn't even matter whether they're happening on this browser or on another browser. We'll see that in a future episode. That'll be subscribing to facts. But it's all the same API. And it all just ends up working and being, in my opinion, very, very beautiful. So here we have, yeah, let's go ahead and fix this spelling. So submit message. So that is, yeah, that's fixed up there. Here we have the channel being passed down, or being hard-coded here. I don't want to hard-code it. I want to pass it in this .props .channel. It should be one of the properties of the submit form. The submit form is used here in the app. So submit form channel is equal to this .props .channel. Remember, that's already a property that's passed into the app. So we're watching this channel, and then the submit form, go ahead and create messages in this channel. I can also use that, like right here, this .props .channel .name. So I want to display the name of the channel. So with all that in place, I should still have my channel. So that's all working. If for some reason I were in the random channel random. There's my message there. Switch to general. And I'm back in general. So I'm using that same channel instance for the watch as well as j.fact, as well as creating the successors. And so that's how you get things hooked up. And that means that, that now I can actually, rather than this being an app for one channel, this can actually just be like the sidebar where I can select multiple channels and then switch from one to another. So this is starting to look like yet another chat app. But it needs some styling. It needs It needs, being able to switch channels. Maybe being able to direct message people. All that stuff. I mean, all that stuff would be great. It would be wonderful to have. But unfortunately, we are running out of time, and Groundhog Day is coming to an end. So you know what that means. You know what that means, don't you? I'll tell you what that means. That means that I'm going to have to remove Yucca. Boom! Everything that we just did, gone. It's Groundhog Day. Wait a minute, not everything that we just did is gone. There's still data in the database, right? Yeah, let's take a look at this. Yeah, here's our select star from public.fact. And look, here's all of the messages and the channels. So you can see there is the channel name random, and here's the channel name general. And there's all the facts that we've added to those channels. Okay, so not everything is gone. Oh, wait a minute. Actually, yes, everything is gone. Let's disconnect from that database. And then psql -h localhost postgres drop database Yucca. It's still being used. Well, I will delete the Yucca database as well, because it's Groundhog Day again. Until next time, this is Michael. Happy Groundhog Day.